Okay. Can you hear me? Mama Hanod. Zoom in cut again, but can you hear me? Hanod. What again, but can you hear me, guys? Online? Hanod. Pain on it. I hope so. Hari. Very Hari. So today we are going to discuss several maths part. First, we are going to discuss what we called indices, and then we'll discuss about the quadratic equation. Before that, let's discuss scientific notation. After that, what we can do, first I'm going to do indices, then scientific notation. After that, proportional concepts like indirect proportion, direct proportional, inversely proportional, likewise. And then we are going to discuss log, finally quadratic equation, and some useful mathematical equations. Yeah, likewise. Have you ready, Cam? Okay, so I have a note also. So we can do some questions, some basic mathematics, all stuff, but we'll do some questions. Okay. I think last supportive maths day, we discussed about the trigonometry. What is sine, what is cos, what is tan, and then we discuss about the standard values. Okay. And then we discuss about the what we called circular quadrants. So that's about the last day part. And then what we can do today, we can move to the next part, mathematics, useful mathematical equations. Okay. So okay, so let's move. Hari, you can ask. I'm checking the Zoom chat. Okay. Man Zoom chat එක බලාගෙන ඉන්නේ. එතකොට අපිට පුළුවන් වැඩේ කරන්න. So first we are going to discuss about the laws of indices. And simple concepts. So laws of indices, these are some questions. Before going to the question, let's discuss about the theory little bit. Okay. But before that, mathematics program, I would like to give you certain notices, what we called about the paper class. Today we started the paper class. Okay. I mean in Rotary. In Rotary we started the main training paper class for 228 students. So you can join with us. In this time we have a separate training paper discussion also. Scheduled for August month in Saturday 7:30 p.m. Saturday 7:30 p.m. to 11 p.m. Okay, we can cover the discussion part. Then total question. I mean, I'm discussing all the 30 MCQs for the MCQ, and in the next week you can get the structure essay and the essay, and I'm discussing that part also. Online students can join. What they can do, they can apply for the online application, online method through the AP site. There is a theory plus online paper separate class card. You can purchase that one, and then you all the papers you can get through post courier services. And then you can we have a separate Zoom sessions, allocated Zoom sessions. What you can do, you can join for the Zoom session and write the paper in that during that time slot. Okay, and then you can submit the paper finally, and then we can mark the paper and provide the PDF back. That's about the online method. But if you can attend physically, it's much better. It's only 1.5 hour paper. for each and every week you will get a 1.5 hour paper MCQ this year, and then next week, not MCQ, sorry, MCQ this week, not the year. MCQ you can get this week, and next week you can get the structure and essay. Likewise, each and every week you will get a separate MCQ plus structure essay, another paper, 2 papers. හැම සතියෙම MCQ මේ සති, ඊළඟ structure essay plus essay again, second paper MCQ third week, fourth week second paper structure essay and essay. 2 structure essays and 2 essays. පොඩි මට්ටමේ ඉඳන් බේසික් ඉඳන් උඩට යනවා ලෙවල් එකට. හරි. So you can improve your experiences, and then that's the way to learn physics. Okay. අපි යමු වැඩේට එහෙනම්. All the notifications, all the guidelines are given through the sites, through the channel, in Telegram channel. You can follow the Telegram channel. Okay. එහෙනම් අපි වැඩේට යමු. So laws of indices. So basic rules, you can see here the rules are given. So when you take 2 numbers having the same base but different indices, same base number a to the power m multiplied by a to the power n. Okay, so you can see what's happening there. You know these stuff, or basics, all level knowledge. What we can do, if there are 2 similar base number, you can see the indexes. These are the indices, so you can add. Simply you can take 2 to the power 2 into 2 to the power 3. Finally you can write this one as 2 to the power 2 plus 3. That means it's 2 to the power 5. A small example, you can see here, if there are 2 numbers, numbers like 2 to the power 2 into 2 to the power 3, so same base number. If there is a multiplication, you can add the indexes, and you can add these indexes, and finally you can write 2 to the power 5. If there is a division, like take 2 to the power 3 over 2 to the power 2, then what we can do, you can take the difference. Okay, it's a simple thing. Again, you can take the difference. හරි, මම මේ පොඩි තැනින් ඉඳන් පටන් ගන්නෙ. කට්ටිය බය වෙන්න එපා. I'm going to the deep concepts also. So we can take 2 to the power 5. Let's take 2 to the power 5 divided by 2 to the power 2. So then you can represent this one, same base number again, 2 to the power 5 minus 2. Okay, you can take the difference. Then it's you can write that one as 2 to the power 3. 2 to the power, I'm giving an example here. So here you can see what's happening. And the next one is, you can take that same base value again. We can write 2 to the power 3 to the power 2. අර බලයක බලයක් වගේ. හරි, බලයක බලයක්. So 2 to the power 3 to the power 2. Then what we can do, we can write this one as a multiplication, 2 to the power 2. Hurry. So we can write 2 to the power 3 to the power 2 can be written as 2 to the power 3 into 2. Like a multiplication, you can write that one as just a multiplication. Then 2 to the power 6. Okay. මෙතන මෙහෙම බලයක බලයක් කියලා කියන්නේ බලයක බලයක් අපිට නම් ගුණිතයක් විදිහට ලියන්න පුළුවන්. So these things, all these things are carry out or related to the same base number. Some other important things. So let's take now same index, 2 to the power 2 into 3 to the power 2. Okay, so මෙහෙම තිබුණොත් එහෙම what we can do, we can take that base index number out. You can write 2 to the power 3 into 2. Simply ඉස්සරහට හම්බ වෙනවා. හරි, you can add ab squared, then you can represent this one as a squared b squared. ab squared can be written as a squared b squared, and other way around, we can write in other way also. When there is a squared b squared, you can take that squared out, and you can write ab total squared. ab total squared, these are very important. Remember the concept. ab total squared can be written as a squared b squared. and other way around also acceptable. හරි ඔච්චරක් නෙමෙයි අපිට කියමු xy to the power 3, then you can represent this one as x to the power 3 y to the power 3, and if you have something like that, x to the power 3 4 y to the power 4, you can write xy to the power 4. This is very important, remember that. But here this is not correct. Sometimes you are doing this kind of mistakes. Here this is a multiplication. You can take ab squared. ab squared. When you ලියා ගන්න ටක් ගාලා පොතේ. Just write the rules. Write down rules of indices. Just take another book or separate A4 sheet. Write down the heading rules of indices. And put these rules. If you want, you can take an example also. ටක් ගාලා ලියන්න. Take an example. Write down these examples up to this one. Just ටක් ගාලා ලියන්න. This is the rule and this is the example. And here this example, this is 6th. I'll move to the 6th one directly. That one also similarly. You can take 3 to the power 2 divided by 2 to the power 2. Then you can represent this one again, 3 over 2 to the power 2. Okay. The other way around also correct. Sometimes we need ab squared. Then you can write this one as a squared b squared. මේව ඕනේ නෝ හරි. 6th one. Then 5th one is also very common idea. When you take 1 over 2, simply you can take this one as 2 to the power minus 1. Another way around, let's take 2 to the power minus 2. Then you can write this one as 1 over 2 to the power 2. Okay. Let's take 1 over 2 to the power minus 3. Then you can take this one as 2 to the power plus 3. උඩට ගේන්න තියෙන්නේ. When there is 1 over 2 to the power minus 3, you can bring this one to the numerator, 2 to the power plus 3. This is minus 3. When you take to the numerator, it becomes plus. Okay, so complete. The 5th one also very important. These things are regular practices. You need to do this kind of regular practices when you are doing the calculations. Rules of indices. First, you can see same base but different index values. Same base, then this is division, then this is the power of a power. And then now these two are different indices but same, sorry, different base values but same indices. And then you can write in this way. So here is 1 over value. So you can take, if it is 2 to the power minus 2, then you can write 1 over 2 to the power plus 2. 1 over 2 to the power, or other way around, there is a 1 over 2 to the power minus 3. Then you can take that one to the numerator and then you can see the plus value. Write down certain examples. It's super easy, but sometimes you are doing mistakes when you are calculating. So this is the 6th example. Okay. So these are the rules. Remember the concepts. These are the first example. This is the second example, third example, fourth example, fifth example, and then sixth example. Okay. I will provide this note after the discussion, but you can create your own note. Then some students sometimes doing these kind of mistakes. So here we can see this one. I explained that one also here. When you take AB squared, you can write this one as A squared B squared. That one correct. Let's take there is expression A plus B squared. You can't write you can't write or it's not equal. So you can simply write it's not equal. The symbol of not equal is something like this. This is not equal. A square plus B square. You can't write like that. Can't. This is incorrect. I mean not equal. Okay, remember the concept. You can't write like that. You can't expand the equation in that way. You can't. A minus B squared also you can't write like in this way. AB squared, this one also correct. AB total is A over B. A over B total squared is correct. You can write A over B like A squared over B squared. This one is also correct. This is correct. This is correct. But these values are not correct. Not only second, I mean squared terms, but let's take whatever fraction to the power 3. You can't write like that way. Again, මෙහෙම තිබ්බත් ලියන්න බෑ කියලා. I mean a minus b to the power 3. You can't write in this way. You can't. මේක වැරදි. හොඳ. එහෙම ලියන්න බෑ. There are expansions. There are ways to expand that one. For A-level physics, you can use the quadratic equation, not for the other power values. Quadratic equation, these are then known as quadratic equation. Let's see separately how to expand something like that. But you can't. You can't expand in that way. Let's see how to expand it. Okay. බලමු කොහොමද කරන්න කියලා. But දැන්ට මම තියාගන්න එහෙම කරන්න බෑ. You can't. Then I'll add a note later how to expand this one as a pattern. But here remember that you can't write in this way. I'll explain how to expand it. Okay, so you can see there are some questions. You can try. There are some questions. I'll give you 1-2 minutes. Just a simple answer. You can write down the answer here. So question 1, you can practice with me. So you can 3 to the power 2 into 3 to the power 3, same base. Then you can write 3 to the power 5. Here there is a multiplication, but it's minus 2. It's like a division. You can represent this one as 2 to the power 5 divided by 2 to the power 2. But no need. This one is also similar. I mean, these two are similar behaviors. Okay, no need to write like that. Just take the addition. So plus 5 minus 2. You can take 2 to the power 5 plus minus 2. It's somehow again a difference. Then 2 to the power 3. That means 8. Here, how do you solve this one? So you can see same base value. same base value, but 3 is not a same base value, so you can't make these two, you can't write all, you can't represent this one is a one equation. You can write 2 to the power 5, 2 to the power 3, it's 2 to the power 5 plus 3 into 3 to the power 2. These are two different base values, so you can't add these two together. So then you can add 2 to the power 8 into 3 to the power 2. Or if you want, you can write, you can see there is 2 and this one is 8 is 4 to the power 2. So you can, if you want, you can write 2 to the power 4 into 3 to the total, for the total term you can take again to the power 2. If you want, you can represent this way, but no need, but can. This is enough. Okay. How did? So then this one, you can see it's a to the power 2x into a to the power 5x, then a to the power 7x. Just add 2 plus 5, 7x. This is 2x. This is one term 5x. So 2x plus 5x is 7x. This one. So you can see actual formation of this one is 2 to the power 2 into x to the power 5 into 5 times x to the power 3 divided by 10 times x to the power 2. Then how do you solve this? You can solve the numbers, these coefficients separately. These are like coefficient 2 to the power 2 into x to the power 5, 5 into x to the power 3. So these numbers are just numbers. So as a multiplication, then you can see 2 into 5, 10. Then this is also 10. So you can cancel out. So finally you can write this one is 10. This is x to the power 5, x to the power 3. So you can take the numerical numbers, you can separately write in that way. So what's happened to the x term? So it's 5 plus 3 minus 2. Finally you can represent that one. 10 is cancel out, is 1. So actual value is now x to the power 6, x to the power 6, because this one is 1. Your coefficient becomes 1. 2 to the power 5, 2 to the power 5, 10 divided by 10. So what's happened to the x values? You can calculate in that way. Okay, this one. So here you can see it's a to the power 2 to the power 3. That means a to the power 6 into here a to the power 3 into the power 2 means again a to the power 6. Finally a to the power 12. A to the power 12. Okay. Harid. Yeah. So then last one. Practice. Take a practice. These are practice questions. So then you can see here in this question, here there is a x to the power 2, y to the power 2. Within the brackets, there is a to the power 3. So then we can write x to the power, I told you that one. We can represent ab squared in, I mean, if you take ab totally squared, you can again represent that one as a squared b squared. Likewise here, x to the power 2, y to the power 2, again to the power 3. So you can separately multiply these values. So then x to the power 6, y to the power 6 divided by, it's a division, okay, divided by here x to the power 6, y to the power 4. You can see if you multiply it separately, x to the power 6, y to the power 6 divided by x to the power 6, y to the power 4. 2 into 2, 4. So you can see x to the power terms are cancelled out. Here, dot multiplication. Then multiplication x into x to the power 6 into y to the power 6 divided by x to the power 6 into y to the power 4. This is a division. So you can remove this term. It's like it's cancelled out. Then you can see y terms are there. It's a common base. Then you can write y 6 minus 4 means it's y to the power 2. Final answer y to the power 2. It's very simple method. Okay. So likewise, you can practice these questions, very simple ideas. So indices. So these are the simple practice question for indices. Okay, if you have any question, you can ask. මම YouTube chat එක නම් බලන්න නෙමෙයි ඉන්නේ. හරිද? Okay. So now let's move to different another type of questions. Fractional indices of power. Okay. So fractional means nothing but okay. This is nothing but in like 2 to the power 2 to the power half. 2 to the power 2 to the power half. Okay. Take a simple idea. නැත්තම් මෙහෙම හිතමු. අපි ගමු මේ example එක. Let's take 4 to the power half. නැත්තම් simply half means square root. Square root of 4. Square root of 4. This is nothing but square root of 4. So then half means again that one is a power. What we can do? So you can see the 4. This one can be represented as 2 to the power 2 to the power half. Then we can represent this one as 2 to the power 2 into half. We know that. We learned that when there is a to the power m to the power n, you can write amn. A to the power mn. Likewise, you can represent in this way. Finally, 2 to cancel out, and then 2 to the power 1 means 2. You know that kind of behavior. So this one, so normally we can represent square root of 4 in this way. So then if you just write the symbol, if you just represent the symbol, the meaning of that one is take the half value to the half power. But if you won't represent, take the here, let's take something like this. I need give me a second. I need so you can write down this one also. Okay. So fractional indices. So let's take I need 8 to the power 1 over 3. 8 to the power 1 over 3. So here we can represent this one in this way. So you can represent here before in front of the square root term. Now this is not square root actually. This is take the 1 over 3rd power. The idea here is you can represent this way. 8 to the power 1 over 3 can be represented this way. So let's take you have a term. You need to get a half 1 over nth power, a to the power 1 over n. Then you can represent this one as n square root term into a. I mean inside that one you can represent a. So this is that representation. You know this one, this hat represent the power. Okay, this hat represent the power. It's another representation to represent the power. Okay, this hat. So you can write a to the power 1 over n can be represented as n square root of a. I mean n means not the n, this is not the multiplication. I guess just a representation. හරි. අර එහෙම ඉස්සරහින් 3 කියලා තියෙන්නේ. This is not a another multiplication, just it's like above the square root term you need to put that n. Now you know this one is not a square root, this is a to the power 1 over n. So you can write 8 to the power 1 over 3, you can represent this way. And then how do you solve this one? You know 8 means 2 to the power 3. So I can write answer is again 2. Okay. Some of the examples. You can write some of these examples. So let's do this example. Okay. So let's take this example. Let's take this example. So this one, first one. So here, first example, it's again, it's like 125 to the power 3 to the power 1 over 3. This is the representation. Then you can see it's 125. This one, this is 8 over 125 to the power minus 1 over 3. To the power minus 1 over 3. මේකට හැර දැකලා තියෙනවා. හරි 8 is 2 to the power 3. 125 5 to the power 3. What I had දැකලා තියෙනවා, you can get that one. 3 to the power 3 sorry 2 to the power 3. This is 2 to the power 3. This is 2 to the power 3 and this one is 5 to the power 3. Okay. So now you can simplify this one. It's 2 to the power minus 1. So when you multiply this one, it becomes minus 1, and here this one also minus 5. So what we can do, you can write 1 over minus 1 over 5 to the power minus 1 means you can take reciprocal. Reciprocal karna can take the inversion of it, like 5 over 2. Okay, reciprocal. When you take the one, if you change that upside down, then it's known as reciprocal. Okay, so here 1 over minus 1 over 5 to the power minus 1 means you can take to the numerator and we can represent that one as 5. Here 2 to the power minus 1 means it's like 1 over 2. Okay, so remember these small indices examples. Do that one. I'll share this document after the class. Then this one. So here you can represent 8 over 27 to the power 2 over 3. 2 over 3. Okay, so again you can represent this one as I know 8 means 2 to the power 3. divided by this is 3 to the power 3. And now they are asking to take the 2 to the power 2 over 3 to the power 2 over 3. Then what we can do? We can just take this one as a number, a fraction, and separately multiply with the given power. So 2 to the power 3 into 2 over 3. You can write that one as 2 to the power 2 into 2 over 3 divided by 3 to the power 3 into 2 over 3. So finally, so this is 2 to the power 3. 2 to the power 3 into 2 over 3. So 3 cancel out. 3, so remaining terms 2 to the power 2 divided by 3 to the power 2 means 4 over 9. 4 over 9. Here 2 over 8 over 27 to the power 2 over 3. Then you can just expand. You can represent 8 as 2 to the power 3, 27 as 3 to the power 3. Finally, you can solve in that way. This is 4 over 9. This one, you can see this is 10 to the power 4. 10 to the power 4. And asking to take the 1 over 4th power. 10 to the power 4 to the power 1 over 4. So it's like 10. It's 10. Okay. So fractional indices of power means simply, it's not that much hard. Again, when you represent this half or 1 over 3, 1 over 4, whatever, minus 1 over 3. So minus mean again, you can do the same thing. Minus means you can represent that one as a, I mean, let's say finally you are getting 2 to the power minus 1. Then you can represent this one as 1 over 2. 10 to the power minus 4, you can represent as 1 over 10 to the power plus 4. Here I did that one here. So get used to these kind of small questions. Okay, you can try, you can check the answers. Yeah, good. I can see your answers also. Yeah, so now let's move to solving equation involving indices. Solving equation involving indices. I think this one also you have a basic idea. In all levels you are doing this one. So let's take there is equation. Equation means there are two terms connected by a equation sign, equal sign. There are two terms connected by equal sign. If the base values are equal, you can say here if the base values are equal, so here x to the power m equals x to the power n. If the base values are equal, then these indexes or these indices, you can write they also need to be equal. Okay, that's another important theory. Let's take the indexes are equal. Here in this way, you can take x to the power m, then y to the power m. The indexes values are equal, not the base. Then you can represent the base value should be equal. Okay, when x is not equal 0, so if x to the power m equals x to the power n, then you can write m equals n. If x to the power m equals y to the power m, then x equals y. Sometimes you are getting such question. So what we can do here, you can see 256. That is 16 squared. 16 squared means 4 to the power 4. 250 means 4 to the power 4. Now, 4 into 4, 16, 16 into 4, 64, 64 into 4, 256. 16, 64, 256. Okay. So then you can see here 4 to the power x equals 4 to the power 4. Since the base values are equal, you can write the indexes are also, the index values are also equal. X equals 4. So now that's enough for your, there's another equation, let's see. Index values. There is another equation, good question. There is another question. So here this is power mark, okay, this is the power. So here this one is 4 to the power 2x plus 1. Here you need you can represent 1024. I know that one 2 to the power 12. Help because I know in IT they are using 2 to the power 2, 2 to the power 10. Sorry, my bad. 2 to the power 10. 2 to the power 10 is 1024. 2 to the power 10. Well, so 2 to the power 10, 2 to the power බලන්න දෙක හතර. If you are not sure about that one, 2, 4, then 8, 16, 32, 64, 128, 256, 512, 1024. Yes, 2 to the power 10. So 2 to the power 10 I can represent as, so 1024. I would like to write the same base number here because then I can equal the indexes. So 1024 equals 2 to the power 10. Here I would like to represent this one as 2 to the power 2 into 5. අවුලක් නෑනේ දුකක් නෑ. 2 to the power 10, you can write 2 to the power 2 into 5. So that means 2 to the power 2 means 4. I can write 4 to the power 5. I didn't notice that one directly, but I know I am familiar that 1024 equals 2 to the power 10. Then I can represent that value 4 to the power 5. 2 to the power 2 means 4. So then 4 to the power 5. Now the indexes values, then since the base values are equal, we can write the index values are also equal. Then you can write 2x plus 1 equals 5. Then 2x equals 4, x equals 2. Highly easy. Small type of questions. Okay. Hard. So that's about the indexes or indices. And now I'll give these notes. So we learned that a to the power m into summary, okay, just summary. I to the power m into a to the power n equals a m n. Then a to the power m divided by a to the power n you can represent as a m minus n. A to the power m to the power n you can write a m, sorry, my bad, sorry, this is plus a to the power m into a to the power n you can write a to the power m plus n, then plus n. This is minus n. Here this is mn. Okay, මම values දාලා ඉස්සෙල්ලා කතා කරා. Then you can write a to the power minus m 1 over a to the power m. ඒ ටික අපි දන්නවනේ. We know these stuff. This is summary. So let's take now something like this, x to the power x plus 5 to the power let's take x on the bag. Yeah. So similar behavior, you can represent this one as x plus 5 as a one term. You can take x plus 5 as a one term to the power 2 divided by x to the power 2. එහෙම ලියා ගන්න පුළුවන් හනේ. Similar behavior. Not this one, sorry, my bad. A1 ලියලා නැහැ මෙතන. Hi, we can write a to the power m divided by a to the power n a m over n. හරි. මෙහෙම නෙමෙයි පොඩ්ඩක් my bad. We can write that one as a, this is a similar way නේ. හරි පොඩ්ඩක් හො නෙමෙයි. මෙහෙම මෙහෙම දෙයක් අපි කතා කරා ඒක, we did that one also. Let's take two different x to the power 2 y to the power 2, we can write xy to the power 2, and I told you x to the x divided by y totally squared, you can write x squared divided by y squared. අපි ඔය කතා කරා similar behavior. Okay, හරි. Okay, හරිනේ, දැන් ලියා ගන්න දෙයක් නැහැ. දැන් මම මෙන්න මෙහෙම දෙයක් කියන්න යන්නේ. So learn this one. So what we can do here, when you take, so these things are okay, I mean you can manage, these are very fundamental things. And some other useful properties. What are the other useful properties? When you take a plus b totally squared, okay, a plus b totally squared, remember the shape. You can take first term, take the first term and take the square of the first term, a squared plus, since this one is plus, you can take that one directly plus. Then take the product of these two, a into b, and multiply it by 2, 2ab. I'm just going to explain you a pattern. A squared, then since this is plus, you can take the same plus here, in then 2 times the product. Again, doesn't matter whether this is plus or minus, just take plus b squared. This is the expansion of square term. This is the expansion of ab squared, a plus b squared. This is the expansion of ab squared. This is xy as a product. Okay, so x dot y squared, you can write just x squared y squared. But here there's a plus sign. So then definitely you can write in that way. So when you take a minus b squared, you can write a squared. Then you can see this is minus. So put minus term here. Then 2ab plus b squared. Just write down these stuff, some useful expansions. Okay. ඔයගොල්ලෝ තුන්වෙනි කෝණ වෙන්නේ නැහනේ, power to the power 3. ඒවත් ලියන්න පුළුවන් අපිට ඕන, but no need. So when you take a plus b squared, you can write in this way. So write down this one, expect note කියලා. මේක ඕනේ. Here up to this one we learn this summary. These are the things we learned up to this point, so I will erase that. So now we are going to learn some other important indexes related patterns. Okay, මේක derive වෙන්න මහ ලොකු දෙයක් නෙමෙයි. You can take a plus b into a plus b. Then you can multiply separately. Then you can take a into a squared, a into b plus ab, b into a, again ab, then b plus b into b, b squared. Finally, you can get a squared plus 2ab plus b squared. This is the expansion. This is the way to expand a plus b totally squared. Again, when you take a minus b totally squared, same way. You can take now a squared, then a into minus b is minus ab, minus b into a, again minus ab, then b minus b into minus b, you know minus minus product is plus, plus b square. So then you can write a squared minus 2ab plus b square. Write down that one. No need this one, just remember the pattern. Easy. So then let's take example. Let's take example. මොකද example? අපි ගමු 2x plus 1 total squared. 2x plus 1 total squared. Then you can write 2x squared plus 2 times 2x into 1 plus 1 squared. That means 2x squared means 4x squared plus 2 into 2 4x plus 1. That is the way to expand it. Let another one. X minus, we have 3x minus 2y squared. 3x minus 2y squared. So how do you simplify that one? Take the first term, take the power of that. 3x squared means 9x squared. 3, you know that 3x squared means you can write 3 squared x squared. That means 9x squared. You can directly write that one in your calculations. I mean, in your head, you can calculate in that way. So then minus, since this is minus, you need to put minus here. Then you need to take 2 into 3x into 2y plus 2y total squared. That means 4y squared. Here you can finalize 9x squared minus 12xy plus 4y squared. Three x minus 2y total squared equals 9x squared minus 2 times 3x times 2y plus 4y squared. Then you can simplify that one. You can expand that one in this way. හිතීම ගන්න පුළුවන් 3 වරක් 2 6යි 6 වරක් 2 12යි. So minus 12. 3 into 2 6, 6 into 2 minus 2. So minus 12 xy plus 4y squared. Yes, good. Okay. Let's get another example. 2x squared minus, let's take one, come on, squared. No need to worry about that. There is another term, that term has a squared, no need to worry. Let's take this one is 3. Then let's simplify. This is just 2x squared. Then you can take 2x squared to the power 2. Hitting when you after practicing. Then you can write 2x squared. That my first there is a 2 into 2. Okay. So you can take 2 into 2 to the power 2 into 2x squared into, this is minus, so this is minus, and then into 3 plus 3 squared means 9. So you can write now 4x to the power 4, x to the power 2 means 4, minus it's 12 x squared plus 9. 2 to the power x to the power 2. Hard. Okay. Yes, good. Then let's move. I mean, this one is not needed, but for the completeness, I will provide ornament nair. Honey. Sorry. You don't need this one actually. You don't need this one. නිකන් කියන්නේ. So when you take give me answer. Erase එක පොඩි අවුලක් තියෙනවා ඒක. ගණන් ගන්න එපා. හරි. So when you take this one, this is not important, but I'll give you a plus b to the power 3. This is also a pattern. You can take a to the power 3, then 3 times you can reduce the number index number of the first symbol. Let's say first symbol is a, so a to the power 3, b to the power 0. B to the power 0 means 1. Then 3 times a to the power squared. You can reduce the number. This is 3, this is 2. Then increase the number of the, you can increase the index of the b. It is just b because I told you this is a to the power 3, b to the power 0. Then you can see this one is reduced by 1 value and b increased by 1. b0, this is b1 now. Then plus 3ab squared plus b to the power 3. Oh, nah, so this is the expansion, another expansion a plus b to the power 3. Okay, ලස්සන තියෙන maths කාට ඉගෙන ගන්න ඉස්සරහට. හරි, there is a pattern like a triangle. You can create how to whatever like a to the power a plus b to the power 5. You can identify these numbers using a different method, pattern. I'm not going to explain those stuff. So likewise, you can identify whatever power by following these patterns. So there are certain patterns. Pattern තමයි math ගොඩක් වෙලා pattern තියෙනවා. So you can learn patterns and identify the answer. So if it is a minus term, again there is a pattern. So you can take the first term, then again for second term is a minus 1. Third term again plus 1. Fourth term is minus 1. You can see here check the number of check the value of the a, power value of a, 3, 2, 1, then again 0. b, 0, 1, 2, 3. And here these two get that coefficient 3. If it is minus, this one become minus and this one also become minus. But no need. No need that much. I just gave you for the completeness. But I think you are learning this stuff. In all you are learning. Yeah. In all you are learning this stuff. That's why I'm giving for the completion. Just take that pattern. It's easy, super easy. Other important thing for the A level, when you take difference between 2 squared, this is not a minus b squared. These are totally different. When you take a minus b squared, you can see this 2 is there for the total number, not for each number symbols. But here a squared minus b squared. Okay. So then when you take difference between 2 squares, then you can represent this one. Another important property, a minus b, a plus b. You can see when you expand this one, a squared, then a plus ab. Here it is minus ba minus b squared. So these two cancel out. Finally, you can get this one. Okay. So you can see difference between two squares. You can represent this way. Sometimes in the exam, you need this kind of mathematical calculation. Let's take example. I'm taking example. In the exam, there is a value that there is a calculation. Inside the calculation, there is a term like let's take 16. අපි ගමු මෙහෙම. Come on, 16 to the power 2 minus lazy gum. Yeah, you have something like this. You need to calculate. You don't know square term of the 16. If you know, you can 256. අපි මෙහෙම හිතමු. There is something like this. There is something like this as a calculation. You need to get the final answer. Then what we can do, you can find the 16 squared separately. You can find the 6 squared separately, but it takes more time. So what we can do here, if there is a difference between two squares, you can write 16 squared. You can take the difference between two and the addition between those two and take the product a minus b plus into a plus b. So 16 minus 6 into 16 plus 6. So then you can write this one as 10 into 22. That means 200 square root of 220. Finally, you need to find the square root of 220. If you are not familiar with that number, then you can use the log. Let's see how to find this kind of values using log. Square root of 220. Then after that, you can use the logbook. Okay, good. Hi. So මෙතන පස්සේ log බලන්න පුළුවන් අපිට බලමු අපි. හරි. If you are not familiar with this one, or else you can represent this one 20 into 11. තව පොඩ්ඩක් සුළු කරගන්න පුළුවන් ඕන. We can just run, but I think there is no additional advantage. Just I think we can represent this one as 4 into 55. Root 55 you can't find, but we can write 4 into මේක ලියා ගන්න පුළුවන් ඕන. We can represent this one as square root of 4 into 55. Then we know this is multiplication. You can use the square term separately, and then you can represent this one as square root of 4 into square root of 55. So square root of 4 is 2. You know that one. Then we can write 2 root 55. අපි කෙටියෙන් කියන්නේ we can take that 4 out. If you take the 4 out from the square root term, it's become 2. Then 2 square root of 55. This one you need to find. Okay. So likewise, so using log you can find the root 55. Let's see. අපි කතා කරනවද? Okay. So we learned several important equations. තමයි මේ වගේක් තියෙනවා මෙයාටත් හරි. No need. I mean, we can write a to the power 3, b to the power 3. No need මම නිකන් කියන්නේ හරි. Then you can write a minus b, a squared plus ab plus b squared. Okay, but no need. I'll erase it. You are learning that one in I think in O levels. But for physics, you don't need that kind of calculation. But for maths years, physics වල එච්චර ගොඩාක් අමාරු calculations ඉන්නේ නැහැ. We are not getting that kind of calculations normally. Okay. Yeah. So then we can, now we learned several important equations here. A plus b totally squared, a minus b totally squared, then a plus b to the power 3, a minus b to the power 3. Those things are also not that much important. But again, we need a squared minus b squared, difference between 2 squared. That one again important. Okay. Then now that's enough. नहीं तो चलो तब okay महालोक दे अन्य regarding the indices and some मेरे क्या है so these things are known as binomial expansions. The correct name for this one is binomial expansions. Binomial. So there are two terms. You can see binomial expansions. If you are doing maths, you can see we are going for tail expansions, other important, I mean complex situations. Okay, to get whatever a plus b to the power n, a plus b to the power n, whatever the general equation is there. It's around there. So this one is known as binomial expansion. There are certain patterns. You can follow the pattern, but if it is a large value, you can take the Taylor series and there are some other series. Okay. Now let's move to the next part. Now I think that's enough for your level. For physics, that's enough. That's you need those kind of calculation for I mean you need these kind of patterns, methods for the simplification. Hari, are you ready? Then I'm going for the scientific notation. This is really simple. This is really simple. You know what is meant by scientific notation. So this is important because when you represent your final values, final answer, it is easy to keep that one with the scientific notation. When you when you solve your answers, keep the answer in a scientific notation. It's easy for you as well as the examiner or the paper marker. They can easily identify your values, or simply in the exam sometimes we have you know charge of an electron. Okay, then it's a sound velocity, velocity of light. So if it is a large value, you can shrink it or you can represent it another way using the scientific notation. Writing a number as a product of number between 1 to 10 and a power of 10 is known as scientific notation. So you can see an example. You can represent 523 in this way, 5.23. So you can see writing a number as a product of number between 1 and 10. So here when you take 523, you need to convert that one, you need to represent that number a product of number between 1 and 10 and a power of 10. So this is that value in between 1 and 10. 5.23 is in between 1 and 10. And then power of 10. This is power of 10. Okay. So you can represent whatever value. So when we can value, so let's say there's a large number. It's really hard to read that. Okay. So then what we can do? We can represent this one as 3 into 1, 2, 3, 4, 5, 6, 7 to the power 6. 3 to the power 6. Okay. Just representing that way. It's super easy. If it is a smaller value like 0.1, then you can write 1 into 10 to the power minus 1. Here 1 into 10 to the power minus 2. Here 1 into 10 to the power minus 3. Or just you can keep just minus 2. Doesn't matter. You can represent 1 into 10 to the minus 2 or just keep 10 to the minus 2. That's totally fine. Okay, so this is the scientific notation. You can keep a whatever value, whatever number in between, I mean, as a product of a number between 1 and 10 and a power of 10. It's easy to read. When expressing a number between 0 and 1 in scientific notation, the exponent of the power of the 10 is a negative power. So if you represent a value in between 0 and 1, like 0.0002, I'm taking a value 0.0002 is in between 0 and 1. So then you can represent 2 into 1, 2, 3, 4, 10 to the minus 4. 2 into 10 to the minus 4. ඇතරම වෙන්නේ මේ 2 එකේ ඉඳන් ගණන් කරන්න ඕනේ. You need to count with this 2, 1, 2, 3, 4, or else just count the number of zeros. Easy. Including this one. So you can count the number of zeros in front of the 2. So then you can 2 into 10 to the minus 4, including this one. Or else count the total decimal numbers like 1, 2, 3. So let's take 21. 0.21. Don't, I mean, when you pronounce this one, don't pronounce that one as 21. When you pronounce, you need to pronounce 0.00021. 21. So then you can write this one up to this first decimal point. There are 4 digits. There are 4 decimal points. Up to this one, there are 4 decimal points. Okay. So then we can represent this one as okay. We can represent this one as ekai, dekai, tunai. You need to multiply, or you can you need to bring 4. You need to bring 4 points or 4 places. You need to bring this one 4 places. Okay. So then you can have 2.1 into 10 to the minus 4. Or simply count the number of zeros in front of the 2. 1, 2, 3, 4. So you can write 2.1 into 10 to the minus 4. Hari. So let's represent this one in scientific notation. So 200, 2 into 10 to the power 2, 7.28, 10 to the power 2, 1.25, 1, 2, 3, 4, 10 to the power 4. Here 3.688, 10 to the power 2. Yeah, we need to bring this decimal point here. For that, you can add 3.688 in 10 to the power plus 2. Here 5.7789 in 10 to the power 1. Here you can keep it like if you want to write in that scientific notation. Here 3.56 into 1. 1 means 10 to the power 0. Remember that. So whatever, I mean, if you take whatever x and take the 0th power, then that one becomes 1. If you take whatever symbol, whatever number and take the 0th power, then it's become 1. Let's take 10 to the power 0, it's 1. 2 to the power 0, it's 1. Whatever value with the 0 power, you are getting 1. So here you can represent this one as, if you want to represent in scientific notation, 3.56 in 10 to the power 0. But no need, we are not representing that way. Just keep 3.56, that's enough. So this one 8.4 in 10 to the power minus 1. This one 7.8 into the minus 4. Here this one 5 into 10 to the minus 6. Okay. So you can represent any number in this scientific notation. So it's super easy again. Okay, if you have any question, you can ask. chat එක පොඩ්ඩක් බැලුවා. Okay. Okay. Hari, expressing scientific notation in normal form. That means if there is a term in scientific notation, how do you convert it into normal form? It's really super easy. So if the power of 10 is positive, move the decimal point to the right by a number of places equal to the power. If there is if there are not enough decimal places, add zeros. So පොඩි කාලේ නම් කරලා තියෙන දේවල් no need to do that. I mean no need to think and write. Just 1.35 10 to the power 4 means you know 135 අපි තුනක් දෙකකින් ඉස්සරහටම තව දෙකක් මදි වුණා. හරි. So you can put another two zeros. So they are asking if the power of 10 is positive, move the decimal point to the right by a number of places equal to that power. So here this is 4. So I can move two numbers to the right side, to the left side, okay, whatever, to this other side. But there are another two remaining 10 to the power 2. I can represent this one as 135 in 10 to the power 2. I move by two places, but still there is another 2, then you can add zeros. If there is a minus term, if the power of 10 is negative, move the decimal point to the left by a number of places equal to that value. Okay, so you can write 2.5 10 to the minus 3 like 0.0025. So here we can write it's 35. Here we can write 450. Sorry, 540. Sorry, 540. 540. These are super easy. But for the completeness, I am explaining. Can you write this one? But normally in the exam, if the values are given in the scientific notation, substitute the values also in the scientific notation. As example, we learned linear motion equation. Let's take as an example, there is a s 2 to the power 3 meters. That means it's 2 kilometers. 2 kilometers. Okay. Then u is given in let's take u is given in 20 ms minus 1. Acceleration is 0.002 ms minus 2. They are asking time. So I would like to write these numbers in scientific notation. Make an attack amaru. I'm not going to solve it, okay? So no need to worry, because then you are getting again a quadratic equation here. Yeah, you are getting a quadratic equation, but no need to solve that. I'm just explaining the way that we are substitute. So let's take this one is in the exam. This one is also given in 2 kilometers. This one is given is 2 kilometers. So then we can write this one as 2 kilometers 10 to the power 3. This is 20, so okay, I would like to keep 20 in that way. So here it's 2 in 10 to the power minus 3. So when you substitute, s equals ut plus half at squared. S is 2 in 10 to the power 3 u 20 t plus half into 2 in 10 to the minus 3 to the t squared. Substitute when you substitute the values, substitute that what we call scientific notations. It's super easy then. Okay, so I'm not going to solve this one. It's really hard. I mean, we don't know whether there are roots or not. Okay, so likewise, you can no need to convert it back to the norm form. Just substitute the values to the scientific notation and keep the final answer also in scientific notation. So here this is two. If you want to convert to the normal format, normal form. If you want to keep in normal form, then this one is 2, 4, yeah, in this it's 24,000. 24,000. This one 5, 2, 3. There are remaining 3, 10 to the power 3. So I shift this decimal point to the right side. And I shift the decimal point to the right side by 2 places, but still there are another 3 places, so we can add zeros. Okay. Now we need to move the decimal point to the left side. We need to move the decimal point to the left side by 1. It's 0.23. Here you need to move that one by 3. That means 0.0035. 1, 2, 3. Yes. Again this one 0.1, 2, 3, 951. If you want, you can again check in that other way. I mean, you can check the opposite direction. If you take something like this, the opposite direction is it's a 9.51 10 to the minus 3. Yes, correct. Here 0.000. එතන බින්දු පහක් දැම්මම හරි 0.000501135. So you can see here the number of zeros equal to the value here. If it is 3, you can see 3 0. If it is 3, 3 zeros. If it is 1, 1 0. Including the this 0, including this one, you can see altogether there are 3 zeros in front of that 9. Here in front of this 1, there are 5 zeros. Okay. So here we did some calculation to convert back to the normal format from the scientific notation. Okay. So I'll move forward to the next part. So because this one is also very easy, super easy. Now we are going to learn about the proportional, indirect proportion. So now up to this point we learn indices and we learn binomial expansions also. Binomial expansion little bit. Okay. Then finally we learn about the what we called first we learned about indices and then binomial expansion. After that we learned what we called scientific notation, and now we are moving direct and inverse proportion. Okay. So this is also really important in physics. When you are doing MCQs, when you are practicing MCQs, this one is really important and it's very useful. Sometimes without using that equations, total, I mean this, if there are a set of equation, no need to write the full form of the equation. Just identify the required terms. As an example, let's take there is an equation like this. Still, I think you are not still familiar with the gas laws. In chemistry, you are learning gas laws. But let's take simple gas laws in, I think in all levels you are learning, I'm not sure, but there is an equation known as PV equals nRT. PV equals nRT, ideal gas equation. P is the pressure, V is the volume, N is the number of moles, R is the constant, T is the temperature. R is known as universal gas constant. So we have a such equation. In chemistry also you are learning, physics also we are learning. P pressure, V volume, N number of gas moles, number of moles, R universal gas constant. T is the absolute temperature in Kelvin. Let's take for the same substance, for the same gas sample, samples, we know N is a constant. R is anyways a constant. If you identify N is a constant, R is a constant, and let's take P volume also constant. There is a system. There are a number of moles. There is a gas, and N is a constant. R is anyway is a constant. V volume is also constant. If you identify these things are constant, we can simply write P equals K into T. We can just write P, all these are constant, K is a constant. K is a constant. Because all the other terms, no need to write. Our important properties are P and T. So I can introduce a proportional constant. This one is known as a proportional, just a constant. So then what we can do, we can remove this one and use proportionality. This is known as directly proportional, direct proportional, a symbol. Then you can write P depends on T. That behavior, that relationship is P direct proportional to the T. Because since other things are constant, you can represent this K is just a constant. So it's not, P is not depending on this K. P is only depending on the T. Then we can write P direct proportional to the T. That is a symbol. Direct proportional. So without using this equation, when there is a question, if you identify all the other things are constants, PV equals nRT, but V is a constant, N is a constant, R is a constant, then we can represent P direct proportional T. You can remove this K. Okay, but if you want to make it an equation, again you can add that K. K is just a proportional constant. That K is known as proportional constant. Okay, that K is known as just a K, proportional constant. There are other symbols like K is Boltzmann's constant. This is not the Boltzmann's constant. There are another constant. It's not the Boltzmann. Just whatever K. I mean, simple symbol. This is a symbol to represent that this is a proportional constant. Proportional constant means since all the other things are constant, we can introduce one term P equals KT, and then I can remove that one and use this directly proportional symbol. Or let's take there is a direct proportional symbol. If you want to remove that one, we can introduce this proportionality or direct proportional constant. I think we did that with the dimensions. So we learned, we identified as example, we did this one in the dimension. Yes, they take the periodic time of a bob. Periodic time of a bob. You know what is meant by bob? Pendulum. So that pendulum is oscillating in that way. Oscillating. That pendulum. So then we identified this periodic time depends on the length. This periodic time is depending on length of the pendulum, but we don't know the whether it is L squared or just L or L to the power half. Because of that, we put L T direct proportional L to the power x. Finally, we identify x using the dimensional analysis. Again, we put T direct proportional G to the power y. And then what we can do? We can represent this one as T direct proportional L to the power x, G to the power y. Okay. And then if you want to remove this direct proportional mark, what we can do, we can introduce a proportional constant, and then L to the power x, G to the power y. And finally, you can use it. You can write the this is K is dimensionless constant. This K is dimensionless constant. This is a proportional constant, but there is no dimension. So then we can compare the dimension of the two sides, like the left hand side and the right hand side, and equal the dimension, and you can find the x and y value. Okay, so we did that method in dimensions. Okay, we did that in dimension. So here we don't need that dimension concept, but here we are learning what is direct proportional. So direct proportional means there are two properties. When you increase this one also increases. It is known as direct proportional. මෙයා වැඩි වෙද්දි මෙයාත් වැඩි වෙනවා. හරි. You can see here මෙතන එන්න ඕනේ මෙහෙම. හරි. So here the symbol is not there. Here direct proportional, you need to take this one as a symbol. A direct proportional m, then b direct proportional, and this symbol is not appeared correctly. මේක හරියට එතනට හදා ගන්න ඕන. හරි. So here the symbol is not correct. We can put a direct proportional m. Okay. So the symbol is not correct in this tute. You can put direct proportional symbol. Here the erase is not working in this one. Okay, doesn't matter. So here we can put direct proportional mark. So here the idea behind this one, a direct proportional m, b direct proportional n. Okay. So the concept is when p increases, t also increases, or when t decreases, p also decreases. There is a directly proportional relationship. Okay. If you take such two relationships like a direct proportional m, then b direct proportional n, if you divide those two, a over b, then this one becomes equal. Direct proportion, you can remove direct proportional symbol by dividing these two. They take a direct proportional, you realize a direct, so in this case p direct proportional t, so we can write p1 direct proportional t1, p2 direct proportional t2. Different pressure, this is different temperature, this is another different pressure and different temperature. If you divide those two, you can write p1 over p2 equal, the proportional mark equal t1 over t2. So when you mark two direct proportional relationships here, and if you divide those two, we can write a over b equals m over n. Equal okay, really important behavior. So in the exam, what we are doing normally, when there is a question, let's say there is a gas law equation, we identified all these properties are constant, then we can simply write p direct proportional t. So then pressure is given like when the pressure, atmospheric pressure, when the pressure is atmospheric pressure 1 in 10 to the power 5, the temperature is 300 Kelvin. When the pressure is double, what is the temperature now? So then you can realize when the pressure double, T also should be double. Or here using this relationship, we can write this is P1, this is P2, P2 is equal to P1. Then what's happened to the temperature? This is 300, this one becomes then 600 Kelvin. It's a direct proportional relationship. That is the direct proportional relationship. Okay. If two different quantities increase or decreases accordingly to the same ratio, such quantities are called direct proportional. You can see here, there are two quantities, they are increasing in the same way or decreasing in the same way, then those things can be defined as direct proportional. If two different quantities increase or decreases according to the same ratio, I think they are explaining about this one, a direct proportional m, b direct proportional n. If you divide, if you take the same ratio, then you can write a direct proportional, these relationships are correct, or we can write such quantities are called direct proportional. In direct proportion, when the values of one quantity decreases, the value of the quantity decreases by the same ratio. The value of the other quantity decreases by the same ratio. You can see that if I double this one, this T also double. If I get a half value of the pressure, temperature also get the half value. That is known as direct proportional relationship. In a direct proportion, if the value of the one quantity increases, the value of the other quantity also increase by the same ratio. Okay, if it is double, this one also double. Okay, so here there is a principle for two quantities that are directly proportional. The ratio between any two values of one quantity is equal to the ratio of the corresponding two values of the other quantities. So now we realize P direct proportional T. Let's take one when pressure is 1 atm, the temperature is 300 Kelvin. Then when the pressure is 1.5 atm, I'm asking, atm is the unit of pressure. Okay, I'm asking the temperature. What is the new temperature? Okay, so you can see, if you realize these P direct proportional T, then the ratio between any two values of one quantity. So any two values in this quantity, I can take 1.5 is to 1 equals is equal to the ratio of the corresponding two values of the other quantity. The corresponding, so 1.5 corresponding value is T, 1 corresponding value is 300. So you can make that equal is equal ratio of the corresponding. That's why I told you, if you realize something like P direct proportional T, it's really important. Okay, so you always, when I'm applying this equation for the papers, you can see I'm always trying to go for the direct proportional relationships. I'm always eager, or I'm always trying to find proportional relationships. Then it's easy to work, easy to calculate. ගානක් දුන්නම හැමසම බලන්න ඕන proportional relationship තියනවාද. Then we can write something like this, and then you can go for the calculations. Okay, so you can see, if you identify P direct proportional T, and for a given pressure the temperature is known, so then they are asking for the 1.5 atm, what is the temperature. So you can see the ratio between these two quantities equal to the ratio between these two, same ratio, same format, and now you can find the temperature. It's equal, that's the important thing. It's equal, සමානයි. Okay, it's equal. Then T is 450 Kelvin. Okay, so you can see there are some examples. The price of five books is 1,500 rupees. Find the price of 8 such book. පහක් 1500ක් කීයද? Simple concept. ඔයාලා එහෙම පොඩි කාලේ ගණන් හදනවනේ. Grade 5 scholarship. If so you can, if you want, you can find the price of a one book and then multiply it by 8. Okay, that's the way that we are normally calculating. Or we can add 5 direct proportional 1500, 8 direct proportional whatever price or price P, then I can divide those two. Then you can write 8 over 5 equals P divided by 1500. This is 1, this is 2, I can take 2 divided by 1. Then 8 over 5 equals 5 direct proportional 1500, 8 direct proportional P, the price. So then I can take P, finally P equals 2400. Using direct proportional relationship, we can get the answer. Okay. So in the vector diagrams, we learned the scales. We can use scales. So here, if a length of 5 centimeter on a certain length, a scale diagram represent an actual length of 60 meter. 5 centimeter represent or direct proportional to 60 meter. 5 centimeter direct proportional to 60 meter. Find the actual length represented by 3 centimeter. Then if you divide those stuff, okay, I would like to divide second from the first one, then 3 over 5 equals L over 60. Then L equals 12 into 36 meters. 36 meters. Okay, proportional relationships. And an important thing is, if you identify any proportional relationship, you can remove the proportionality, or you can remove that symbol using proportional constant. You can write that one. Let's take now, you identify A direct proportional B. A direct proportional B, you can realize that A, there is a property A, that one is direct proportional B. So you know, in the Newton's law, Newton's second law of motion, Newton's second law of motion, we can write F direct proportional, Newton ki no, F direct proportional rate of change of momentum. In your term, F direct proportional to the acceleration. You are learning something like that. That's not that much correct in A levels. So A levels we are learning not something new. The correct version of the Newton's law. I think in your case you are learning acceleration direct proportional to the force, inversely proportional to the m. That's the way that you are learning Newton's law, second law in O levels. Acceleration direct proportional force, inversely proportional m. But okay, that's okay. කමක් නැහැ, but අපි ඊට advanced විදිහකට යමු. F direct proportional to the rate of change of momentum. Okay, so likewise we are using A direct proportional B. So then we can use A equals KB. So this K is known as proportional constant, just a constant, proportional constant. We don't know the actual value of that, just a whatever constant. Okay, so third one, if an item bought for 3,000 rupees is resold at a profit of 20%, find its selling price. Okay, you are learning these things in all levels, ne? Commerce you are doing these profit margins in the all levels, I think. So let's try this one. If an item bought for 3,000 rupees is resold at a profit of 20%. Okay. So no need to think about just let's do this one as just a question. No need to think this one as a proportional question or whatever. So if an item bought for 3,000 is resold at profit 20%, what is selling price? You can take your profit margin is 20%. As example, if you bought something at 100, if you bought something at 100, you would like to keep a 20% profit margin. That means 20 rupees profit margin, and your selling price is 120. If you bought something for 100, and if you want to keep 20%, that means it's 20 rupees, and finally your selling price is 120. It doesn't matter. In this way, I'm using proportional relationships. If you purchase something at 100 rupees and now you are reselling at 120 by keeping a profit margin 20%. 20% means 20 rupees per 100 rupees. 20 rupees per 100. So the finally selling price 120. For then 3,000. For 3,000, what is the final selling price? Then P equals, if you divide those stuff, you can write 3,000 divided by 100 into 120. 3,000 kiyada. So we are doing that kind of rough calculation for simple mathematics. Ne? If you take 100 and if you take 100 and if it is 120, then for 3,000, what is the value? Then you can use the direct proportional relationships. Okay, then its value is 300 into 12, 3,600. 3,600. Okay, good. Now let's move to the inverse proportion. Inverse means it's other way around. If you try to increase one property, other property will be reduced. That is inverse proportional. inverse. Okay, so we can represent inverse proportion using the same directly proportional mark. You can represent the inversely proportional properties using the same directly proportional mark, but what we can do, we can take 1 over relationship, x 1 over directly proportional 1 over y. So you can represent this one, මේක pronounce කරන්න පුළුවන්, x directly proportional 1 over y, x directly proportional 1 over y, or you can directly write x inversely proportional y, x directly proportional 1 over y or x inversely proportional y. When you try to increase y, මේක y එක වැඩි කරන්න ගත්තොත්, if you increase this y, you know as a term 1 over y will be reduced. That means x also reduce. If you increase the denominator, then as a term, as a fraction, you know when you take 1 over 2 and then 1 over 3, what's happening? This one 1 over 3 is less than 1 over 2, and 1 over 10 is again less than 1 over 3 even. So if you increase this number denominator as a value, this whole fraction will be reduced. Okay, so here the concept is when you take x and y, those x and y terms are inversely proportional. Inversely proportional. So this is the way that we are representing inversely proportional properties. Inversely proportional properties. We don't have any other term. What we can do, we can write x directly proportional 1 over y. But when you pronounce, you can say x inversely proportional y. X inversely proportional y. And inverse proportional, as one of the two quantities increases by a certain ratio, other quantity decreases by the same ratio, or vice versa. Vice versa means when you decrease this one will be increased. So you can represent that one again using the same direct proportional mark, but as a 1 over ratio, as a 1 over property, 1 over relationship. So a problem, you can see a given example. A hostel has enough food stores to last for residents for 4 days. Okay, considering this amount of food, answer the following. A hostel has enough food stored to last for residents for 4 days. අපි දන්නවා 12කට දවස් 7කට කැමතිලු. I mean if there are 12 residents, then that food is sufficient enough for 4 days. If you increase the number of residents, then the days, the number of days will be definitely reduced. That one is, first when you read the question, you need to identify whether it is a directly proportional relationship or inversely proportional relationship. See, this is an inversely proportional relationship. When you increase the number of residents, definitely number of days will be reduced. So we can say if the number of residents become 15, is the food amount sufficient for 4 days? No. No, no, can we never know him. Hi. So how many days then is sufficient for? We can take 12 inverse proportional 1 over 4, like some IQ questions. You are getting a general knowledge paper, you know that. Hi. In the exam, in A-level exam, you know, if you are doing bio, you are getting a biology paper, physics and the chemistry. And if you are doing maths, you are getting combined maths, PO and applied, physics 1 and 2, MCQ and instruction essay, and then chemistry 1 and 2. And if you are doing IT, you can get IT 1 and 2 also. Okay, and also you are getting general English paper and general knowledge paper. General knowledge paper, there are 60 MCQs. You are getting a number, okay? You are getting a value. I mean, not A, B, C, D. You can get a number like out of 100, how many answers are correct like that. I mean, what is the result? Final result in, so in my case, I received 84 something out of 100. You can do that. General knowledge, IQ. So it's that paper normally consists of IQ problems. IQ means not that IQ actually. There are 15 MCQs according to my memory. There are 15 from the what we call day-to-day news. Okay, so you can practice that one before the exams. Not that much hard. And there are remaining 45 MCQs coming from the total number of MCQs are 60. Okay, not the 50. There are 60 MCQs. 60 හටක් තියෙනවා 60න් 15ක් 15 out of that are coming from the day-to-day news, like what's happened in that country, what is the current situation, like that. You can get some general knowledge, and then other 45 normally IQ, like grade 5 scholarship logic type of questions. There are patterns. මේ pattern එක දීලා දෙන what is the remaining, what is the others next pattern or shape. Likewise, you can get the IQ paper. You need at least a pass mark or greater than 35 to get into the university. It's really important. To get into the state university, you need about 35, I think 35 years for that GK paper. Hari, okay. That one is easy, super easy. Fail you can practice before one day to the GK exam, or 1 or 2, doesn't matter. So now if the number of residents becomes 15, is the food amount sufficient for 4 days? No. If the number of residents becomes 6, how many days will the food amount last? So you can take, if it 12, if there are 12 residents, then it's valid, it's remaining for 4 days. If it is 6, then you don't know the days. So if you divide those two, actually now it is remaining 8 days. If it is half, this one should be double. When you make that days half, this one should be double. If you want, you can divide those two. 12 over 6 equals 1 over 4 or 1 over d. So actually you can take this one to the numerator, you know that. This becomes d over 4 equals 12 over 6. Okay, it's become 8 days. It's really simple. I mean, if 12 direct proportional 1 over 4, then if you make that 6, then days should be increased. But if you reduce the number of residents, then number of days will be increased by 2, by factor 2. So it's 8 make an you can, if you want, you can calculate the remaining days. Oh, so when the number of residents decreases, does the number of days food last decreases or increases? You know, it increases. Make a do not, then it increases. If this amount of food lasts for 12 residents for 4 days, how many days would it last for a single resident? 48 days, I think. 48 days. Yeah. 48 days. If you make that 12 direct proportional 1 over 4, if you take for one person, that 1 direct proportional 1 over d, if you divide again, 12 over 1 equals 1 over 4 or 1 over d. You can write this one as d over 4. Then finally, d equals 48. 12 into 4 is 48. Some IQ level questions. So that one is known as inversely proportional, directly proportional. So inversely proportional we can represent in this way: x direct proportional 1 over y or x inversely proportional y. Okay, good. So now we know what is direct proportional, what is inversely proportional. Proportional or proportion is okay. Now we can move to the next part. Logs. Okay. Laws of logarithm. So what do you think about logs? I think what is the requirement of logarithms. Actually, with this logarithm, we can shrink some ranges. That's you can see we are doing that one in waves and oscillations also. So if you take a range, huge range, you can shrink that one using this log. It's another function which we can reduce the size of the range using this function. You can shrink the range. Let's say there is a huge range, you know, your I mean, you don't know about those values. So there is something on sound intensity. Sound intensity means energy per unit area per unit time. දැන් මම කතා කරද්දී ඔයගොල්ලන්ට ඇහෙන්නේ sound intensity. So to at least to hear the sound, you need to receive 10 to the power minus 12 watt per square meter. Energy per unit time is power. Per unit area means intensity, sound intensity. The maximum you can get without any panning, without any pain. Okay, you can hear whatever you want with the panning. But still you can hear, but without any pain you can get 1 watt per square meter. So you can see there is a huge range. This is known as sound intensity. You will learn that one in the waves and oscillation. Sound intensity. But this range is huge. This is 0.000. There are 12 zeros. 10 to the minus 12. This is known. These are known as threshold values. No need I mean, we are learning this in separately. This one is known as threshold of hearing. This is threshold of painting. Threshold of hearing, threshold of painting. So this range is quite high. You can't actually feel it. මේක එච්චර ලොකුයි හරි 0.00000 ලොකුයි කියලා කියන්නේ නෙමෙයි. Not that what we call the number. This is very small, 0.000000001. But I'm talking about the range. The range. So that range is not easy to imagine at least. The huge range. So we can represent 0.0000001. That's also inside this range. Then 0.0003 is also inside this range. It's not that much easy to handle. So we can shrink this one using these log functions, and then we have another property known as decibel. Decibel. Okay. එහෙම දේවල් අපි කරනවා. So using log functions. So now we have something known as log, but what is the actual definition of log? I mean, here finally we can usage. You can see this one in our physics equations. So we can define this one is known as reference I naught, and then you can divide the whole expression by this I naught, and then convert the log function. This is known as sound intensity level, decibel. Okay, sound intensity level. Okay, something like this. So no need, I'll erase it. But I just want to tell you that there are some equation like this in our syllabus. But what is the, so then you need to know about the log calculations. So you need to know about the log calculations. If there are log equations, then you need to know log calculations. But no need, I mean, let's take there is no log equation, but still you need log to do some simplifications. We are referring log books. Log book. We are referring log books for the simplification. We don't have a calculators in the exam. So you are getting log books. So we need to know how to use the log book for the calculation purposes. Okay, let's try. Do you need interval? Okay, before going to the log books calculation, let's take a break. Let's take a break only 10 minutes, 5 minutes. Let's take 10 minutes break. Let's take a 10 minutes break and join again for this log calculation. So we are going to understand the laws of logarithm, and then how to use the logbook using these anti-log log functions, and then finally simplification using logarithm tables, Pythagoras theorem එක නම් දන්නවා ඔයගොල්ලෝ, you know Pythagoras trigonometry, we did that. Okay. Okay, so we did the trigonometry part last day. So then that's the, so my target to do the logarithm. After that we finish this trigonometry, but after that we can go for the simplification, like simultaneously, yeah, what we call that, I think in this one, that one is not available. I have another tube prepared for that one, for quadratic equation and the simultaneous equation. And after completing this log, I'm going to discuss quadratic equation and the simultaneous equations. Okay, so yeah, so let's take a break 10 minutes and join again. Okay, අපි යමු වැඩේට. හරි. So now let's see අපි I think you can hear me. So now we are going to okay මම ඇහෙනව නේද? අවුලක් නෑ. මම හිතන්නේ මගේ mic එකේ battery ටිකක් අඩුවෙන් ගෙනෙන්නේ. I think it's okay. කමන්න. වැඩේ කරමු. So now I'm going to discuss the laws of logarithm. And what's before going to logarithm, we need to identify what is log. What is the requirement of log? And I told you that there are certain application, but before what is the meaning? So you know, when you take the indices, 2 to the power 4 equals 16. 2 to the power 4 equals 16. Now I want to subject the index. I need to subject the index. Then how do you write that? So I can introduce this log and then log 2, and that is the base number 16 equals 4. This is a way to represent or to what we called to subject the index value. Okay, තේරුණාද scene එක? 2 to the power 6 equals 16. 2 to the power 4 equals 16. And now we can represent that one in another way. Log 2, I think that one is how do we take that one? Give me 1 second. So we can write log here log base b of 16, log base 2 of 16 equals 4. I can pronounce log base 2 of 16 equals 4. Log base 2 of 16 equals 4. So this is a way to represent the represent or subject the index. So then if you get something like this, log base 2 of 16 equals 4, then you can represent this way also. Okay, දෙපැත්තටම හරියනවා. If you know the index relationship, you can subject the index in this way, or if you have this log relationship, you can convert again to the index relationship. Okay, so now and there is another relationship, log base 10. We can write log base 10 of 100. Okay, simply it's 2. We know 2 to the power 2 is 10 to the power 2 is 100. So we can take log base 10 of 100 is 2. So sometimes we are, when we represent a log for base 10, we no need to put this 10. Simply we can use just log 100, or yeah, we can put log 100, or sometimes we put LG 100. That means the base number is 10. Okay, so if the base number is not available, normally our by default we can consider this one is 10. Okay, log base 10 of 100, log base 10 of 100, you can represent that way. So all the other cases for in different bases like 2, 3, 4, whatever, okay, then you need to put the base number below the log symbol. Log base 2 of 16 equals 4. So remember the way to convert log relationship to the index relationship. So now so we can write this one because that one is not available in this tute. What is a log relationship? So this is the log conversion from the index relationship to the log relationship. Okay, so now when you take log terms, log relationships, we have different equations, not equation, relationships. Okay. කොහොමද අපි ඒවා හදන්නේ? So now let's follow this one. I mean, edit කරගමු. So what we can do here, we have several laws related to the log. I think you are familiar with the log in the O levels also. I'll write that equations. When you take log base a of mn, m into n multiplication, we can represent this one log base a of m plus log base a of n. This is one important relationship of log. The other rule is the division, log base a m over n, m over n equals log a base a of m minus log a base of log base a of n. So minus, if it's a division, you can represent this as a minus. Okay. And there are another set of relationships. This is an important one, this is another important one. Then if you take I'll reduce the size. Important relationship log power. And I'll tell you for physics. Okay, for physics we need such a small set of relationships. For maths you are learning different, another important set of relationships. So we can write log base a m to the power n. Then you can take that n in front of the log, n log base a of m. You can take whatever base, doesn't matter, you can take that power in front of the log term as a multiplication. Now it is just a multiplication. Okay, n into, so as example, let's take log simply it's let's take log 2 then 4 to the power 8 as a simple example. Then I can take, no need to think about this base, I can take that 8 in front of the log term. That is just a multiplication. 8 times log base 2 of 4. So log base 2 of 4 is actually 2. Then 8 into 2 is 16. So answer is 16. Log base 2 of 4 is 2. Then 2 into 8 is 16. Okay. So this is an example for this one. And there are another set of equation but not needed for A level physics. One relationship is if you take log a m, you can take that one as 1 over log m a. You can interchange the base and the value. Here log base a of m equals 1 over log base m of a. Okay, so there is another one. So you can take log a, yeah, that's one not needed. That those are some you can learn that one in mathematics using a third symbol, using a third property. You can represent a log term, no need. Yeah, so this one is also not need for you guys. These three are the most important thing. These are the most important three laws. Okay, good. So find the values. So log base 2 of 64. Log base 2 of 64. You can represent 64 in terms of 2. It's easy for that. It's easy for us. We can write log 2. 64 is actually a to the power 6th. A to the power, let's say 2, 4, 8, 16, 32, 72 නේ. ඒක 64 ගාලා පෙන්නේ. 64 and 32 64 no. Yeah, give me one second. No, sorry. 32 then 64, yes. Then it's 2 to the power 6. 2 to the power 6. Log base 2 of 2 to the power 6. Then I can write using this relationship. I can take 6 out, then 6 log base 2 of 2. So log base 2 of 2 is actually 1. So your answer is actually 6. 2 to the power 1 equals 2. That because of the log base 2 of 2 equals 1. Okay. Then for this one, log 5, again 125. So log 5, so 125 is 5 to the power 3. So log 5, log base 5 of 5 to the power 3. Again, you can take 3 out. Then log 5, base 5 of 5 is actually again 1. So answer is 3. Then this one, here you can see addition. So addition again can be written as a multiplication. So there you can see same base number. So if you can see the same base number, you can convert into this one again. So I can write, okay, I can write log 2 32 into 2. Or else I can separately calculate, or else I can combine 32 into 2 because same base number. Then this is 64, log base 2 of 64. Again this one, it's actually 6. We calculated that one earlier. It's log base 2 of 2 to the power 6. Take 6 out, then you can say this is 1. So answer finally is 6. Okay. So then last question here. This one I'll do where I'll do it here. Log 750 minus, you can see same base number again. So log 5, I would like to write that one as 750 over 6. It's a division. So 750 over 6, what is the value? 125. Yes, 125. You can write log base 5 of 125. That means again it's 3. This one earlier we identified. It's 3. Okay. So here we have equations. So let's do this question. Let's do this question. So let's assume this is base 10. All the values are given in base 10. Log here that base is not given. If the base is not appeared, you can consider by default base is 10. Okay, I'll do that question here. Some logarithm equations or simplifications. Before using the log books, let's Okay, I think now you can hear. Non-thermal battery, but I can see now. Sorry for that. Now can you hear? Okay, can you hear now? සද්ද පොඩ්ඩක් වෙනස් වෙන්නේ නැති because now I'm using the laptop original sound. Okay, yeah, doesn't matter. Let's follow this way. ගොඩක් වෙලා ගියේ නෑ නේද? වෙලා sorry. I'll explain that one again. ගොඩක් වෙලා ගියාද? So here I'll explain that one again because maybe the sound is not there when I'm explaining this one. So log base 10x equals, here the question is 2 log base 10 of 2 plus log base 10 of 15 minus log base 10 of 4. So we can represent this one as log base 10 of 2 to the power 2 plus log base 10 of 15 minus log base 10 of 5. So here this is plus. So we can write this is a multiplication, the division. So 2 to the power 2 means 4 into 15 divided by 4. Finally, x equals 15 because here this is same base. So we can take x equals 15. You can take the antilog x equals 15. Okay. Shape name this. Okay, sorry for that. I'm back in. So did you get this one now? Then tell one. So I think I explained this one within that 5 minutes. So this is also similar. So what we can do, take the log, subject the log x and then calculate in this way. You can subject the log x and move the other terms one side. Then you can take antilog and get the x equals 14. Okay, good. So now හොඳට take back in come on. So now this is really important one. So earlier we received something like x equal root 220. So how do you find this one? How do you find this one? So to find this one, we can use the log properties. So let's take the log of the both sides. So I'm using base 10 actually. I'm using base 10. And you know log base 10 of 1, base 10 of 1 is 0. Okay. Because 10 to the power 0 is 1. 10 to the power 0 is 1. So this is the way to represent log value. Okay. So now this is log base 10 of 10 is 1. Okay. So log base 10 of 100 is 2. Now the important thing is something like this. Here, let's take I need log base 10 7. If you want to represent this one in index value, it's like 10 to the power something equals 7. Okay. So here this is 10 to the power 1 equals 10. So actually you can see here 10 to the power 0 is 1, 10 to the power 1 is 10. So if you want to get 10 to the power something equals 7, this something is a decimal value. It's not decimal, it's like a decimal value, is point something. In between 0 and 1, this x value should be in between x and 1. So 10 to the power x equals 7, this x should be in between x and 1. Okay, so let's take I need log 10 as example 200 and then 23. So then you can see that if you explain that take 10 to the y equals 27, 23. So this y should be in between. Or else I can represent this y. I can represent this 23, 2.3 10 to the power plus 1. I can represent this one. Again 10 to the power y equals here 2.3 10 to the power plus 1. Again, now this one is 2.3 something. So we can represent 10 to the power z. I can represent 2.3 as 10 to the power z. So here, this is my requirement. I need to represent 23 as a 10 to the power y. So actually, this y is in between. It's in between 100. 23 is in between 10 and 100. So actually, this y is in between 1 and 2. This y is in between 1 and 2. Simply this 23 is in between 1 and 2. And 1 y, this index value is in between 1 and 2. So you can see here 10 to the power y equals in scientific notation 2.3 10 to the power 1. So I can write 10 to the power 2.3 as 10 to the power z. Okay. So simply we can write 10 to the power y equals 10 to the power 1 plus z. Simple. If you can identify this z, then I can write y equals 1 plus z. So this 2.3 again in between 0 and 1. So 2.3 means again, did you get that point? Wait, so you can see here the concept is log 10 to the power 1 equals 0, log 10 to the power 10 equals 1, log 10 to the power 100 equals 2. So let's take I need log 10 to the power 7. Not 10, sorry, my bad. Power kilogram cubic. Power name, how do we represent it? Log base 10 of 1 equals 0, log base 10 of 10 equals 1, log base 10 of 100 equals 2, log base 10 of 7 equals, we don't know. If you represent in index, 10 to the power 7 equals 7. So I need to find this x. This x should be definitely in between 0 and 1. So let's take I need log base 10 of 23. Then I can write 10 to the power y equals 23. And let's take this one is x. This is y. So this 23 is in between 1 and 2. I mean 10 and 100. Sorry, 10 and 100. This 23 is in between 10 and 100. Okay, that means y should be in between 1 and 2. Y should be in between 1 and 2. This one, if you represent 10 to the power 2 is 100. So here 23 is in between 10 and 100. Because of this, y should be in between 1 and 2. But we can represent this 23 in a scientific notation 2.3 10 to the power plus 1. Because of that, again you can convert this 2.3 or 23 or to something like z. Z is again in between 1 and 0. Or simply, we have a table for these cases. So if you want to find anything in between 0 and 1, we have a log table. When we added log table, so there is someone prepared a table for these values. When we make a 10 to the power x equals 7, they calculate the value of that. So you can see when you follow a log table, okay, when you follow a log table, give me a second. If we log table. Okay, I'll show you log table. You know what is log table? Okay. So we have a log table for those calculations. Like 10 to the power 0. I mean, you know, if I need log 10x7, that one is there. Okay. So here, if you want, so you know how to use this one. If you need log base 10 of 7, that one is 0. So this one is just point. Mark point. There is a point here. So this is 0.8451. Answer is 0.8451. Okay, so here we can use, this is actually 70 means it's not 70. It's here this is 7. I mean, you can see it's 7, and you know how to use it. Let's see. Then the concept is, if you need log 100 again 1. Okay, so the concept is here, if you need log 7, simply you can refer log 7 is here log base 10 of 7. I need this one. So 7, you can directly write the value is 0. You can refer this one 7. This is 7.000. So you can write that one as 0 because I told you that one here it is 10 to the power 1 log base 10, 7 into 10 to the power 1. So you can write that one no, so 10 to the power 0. So my bad. You can write this one as log base 10 of 7 is actually 7 means 7 into 10 to the power 0. So you can represent simply, this is a pattern. We can represent 10 to the power 0. Okay, so here we can represent 0.8451. The concept is 10 to the power 0.8451 equals 7. 10 to the power 0.8451 equals 7. This is the concept. How did the table make? So we have a I mean, no need to learn why we need such logarithm. What is the behavior? So the behavior is what they called concept. So we have a set of numbers given in this table to identify the whatever value, like log. If you need log, let's say I need log base 10 9.951 up to 3 decimal points, up to 10 decimal points. So they log. So this is the final carry. So this is a log. I think you are familiar the logarithms. So I will explain directly what we can do here. If you need log base 10 of 9.9951, that means you can refer 9951. So this is 9951. Okay. So you can see this 0.9978 is the answer for the log base 10. What is the given 9.951? Okay. So here up to 3 decimal you can get the answer. Including this one, you can see up to 3 decimal you can get the answer. Okay. So let's take I need log base 10 of, now no need to write the base 10 always, just write 7. I need 7.5. 7.5. Okay, 7.5. So you can write go for 75. Anyway, 75. So you can see this is the value 8751. 0.8751. So all these things I give in between 1 and 0. Let's take I need log base 10 63.1. So you can represent this one as log. So or simply you can represent this 63.1 as make 6.31 in 10 to the power 1. Simply 6.31 to the power 1. So because of that, we can directly write log 10 63.1 is 1 point something. Easy. I told you if you are taking in any value in between 10 and 100, it's 1 point something. If you are taking any value in between 100 and 1000, it's 2 point something. Okay. So using this base 10 to the power value, you can see here 63.1 is 6.31 10 to the power 1. So it's 1 point. So how do you get the 6.31 value? You can take 63.1. 63.1 can we make? So it means 63.0. 63.1 means this one. 63.1 is 8.000. You can get the answer here 8.000. Okay. So get the concept here log 10 63.1, you can see this one is in between 10 and 100. That means 6.31 10 to the power 1. So because of that, it's 1 point something, 1.8000. This is the way to take the log. So let's identify different log values. So let's calculate. So it's easy. I think you know how to read a logbook. So you know the requirement of this one here. You can represent, or you can find out simply. Let's take I need log base 10 of as example 79.12. Okay, I can take four figures. Here there are 4 figures because this table you can use up to 4 figures. Have 79.12. You can see this is 79. This is 1. 2 you can take from here. 2 means this one. Okay, so you can refer 79.12 is 89, 82, 89, 83. So you can represent. This is 79.12 means it's 7.912 in 10 to the power 1. Because of this 1 point, when you represent the log value, you can say 1 point. So 1 point because it 79.12 is in between 1 and 2. So it's 1 point. That value. What is the value? 89, 83. 89, 82 plus 1, 89, 83. So if you want to represent an index way, you can have 10 to the power 1.8983 equals 79.12. This is the concept. If you take 10 to the 1.8983 is 79.12. Okay, good. That is the log methods. I mean, that's the way to use the logbook. Very simple method. Okay. So I think you are familiar with the way to use the logbook. And okay. So here I want to explain you that log 10 of base 20, so log base 10 of 23, as I mentioned, that value should be in between 1 and 2, but 1 point something, that something can be identified, that something, the z1, the something can be identified using that same table. The y is 1.1 point something, that something is, we are using that table. That's the concept. So how do you find whatever log value? So you can see here, if you need 5, 350, so you can see there are several values. Okay, then what we can do? So let's calculate. Let's try to figure out log 5. Do you have a logbook? Then I need to. So I'll give that one as homework. You can check. So we'll take 75 point. I think we can't take this one. There are multiple figures. You can only take up to 4 figures. Maximum figures perhaps. So then you can round off 75.50. Okay, so let's take random values. So I would like to find the log. This one 75.502, but you can't. There are 5 figures here. So then you can go for 75.50. You need to round off that one up to 4 figures. 75.50. So then I'm going to find the log. I'll erase this one. Okay. So now let's find log. I need log. No need to write the base now. I'm going to use the base 10 of 75.50. So then how do you find that? So you can see it's in between, or it's we can write 7.5. We can write this one 0.7, not 0. 7.550 in 10 to the power 1. So it's it's in between 1 and 2. You can take 1 point something. 1 point To find this 7.550, you can use a logbook 7.550. That means 7550. 7550. 7550. This is the 50. 7550, this one. So you can see, I'll replace the other one. So I need 7550. 7550 means this one. 8779. 8779. You can write here 8779. 8779. Okay, then let's take log 3425. I need log 3425. So then I can represent this one as 3.425 into 10 to the power 3. So it's 3 point something actually. 3 point something. So 3 point 3425. How do you find 3425? 3425. 3425. 3425. So then its answer is 5346. 5346. 5346. 5346. Okay. So this is the log value. So if you want to represent this one, this is a really important thing. So I can take log 0.067. So if you represent this one in scientific notation, 6.3 into 10 to the power minus 2. 6.7 is 10 to the minus 2. So this is minus 2. So this minus 2, you need to represent in front of this dot. But if you put minus 2 here, if you put minus 2 in front of that dot, then problem is the whole expression becomes minus. If you put the minus in front of this one is, you can 7.6 a positive answer. 7.6 is a positive answer. Okay. But this is minus 2. If you put minus here, this whole expression becomes minus. So because of that, to represent this minus 2, we have a different representation. What we can do is 10 to the power minus 2. So here it's you need to represent that one. This one is still positive. 6.7 is positive answer. Here 3.425 is a positive answer. 10 to the power 3, you can put that 3 here. Likewise, this is minus 2, you need to put minus 2 here. But the problem is when you put minus 2, the whole expression becomes minus. You need to put that this one is only the minus, so we can put bar sign. What we can do, we can introduce bar sign. Without using minus, we can use bar. So this is 2, bar 2. Then you can represent that. Then this is actually minus 2 only for this side, not this one. Make part is the minus 2. This is acting as minus 2 for this side. Only left side of the dot. This is acting as only left side of the dot. This is a positive. That's the difference. So think in that way. It's really important. So you can view the in English, you can take these are bars. Bar 2 bar. And then you can take 6.7. So 6.7, you can use this table. 6.3, 67. 30, 67. 67. This one. 82, 61. 82, 61. 82, 61. You can put that one here. Okay. So here, remember that concept. So you can't represent this. If you represent minus 2.8261, that means this whole expression is minus. So we have another way to represent that minus 2 as a bar. That's the concept of this bar. Okay. So here, note a negative characteristic when considering logarithm of numbers between 0 and 1. This is in between 0 and 1. Its characteristic take a negative value. Even though the characteristic is negative, the mantissa, this decimal, the mantissa part from the table is always positive. This is positive. This is the only part is negative. To show that only the character is negative, a minus sign is placed above it as a bar. This is positive, this is negative. So this is another example. You can see 0.175. So you can take, if you want log 0.175, then what we can do? Always think this left side of this dot is a negative. Okay, so this is 1.75 in the scientific notation. It's no minus 1. So you can put bar 1. Bar 1. So now 1.75. Take the log table 17.5. 17.5 කියන්නේ 17.5 17.5 17.5 කියන්නේ 23.30 24.30 24.30. You can write 24.30. Okay, so that is the log value of that. Okay, you can write down the log values in whatever values, like simply you can convert that to scientific notation in your mind. So this is like 7.55 to the power 1. So I can write 1 point something. That's something you can take from the table. Here 3 10 to the power is 3.425 10 to the power 3. So you can take always the 4 figures, only 4 values, 4 numbers, numerical figures. Okay, so if there are 5 numerical figures, you need to round off up to 4 figures. Otherwise, you can't identify this value using the table, because the table only provides maximum amount of 4 figures, numerical figures. Okay. So then likewise, you can calculate any log values using the logbook and the anti-log of it. So that means if this one is given, how do you find the corresponding? So what we can do here, let's take the value, this value is given. Okay, so I need this one. So simply I would like to write in this way. So let's take 3 to the power 2 equals 9. I can write log base 3 of 9 equals 2. Okay, so if you want to remove this one, I mean, we can, if you have this relationship, we can get this index version. Or if you take the antilog of both sides, if you take the antilog, we can write it this way. Or we can, if you take the antilog, I can write 9 equals antilog 3 base 3 of 2. What make a if you want to find this, I mean, if you want to subject 9 again, you can come back to this version or this version. You can take the antilog of both, the log cancel out. This 9 is again, you can subject, and this one becomes antilog 3 of base 3 of 2. Okay, so here the concept is, now we need to find here in this case, let's take now antilog base 10 of 3.5453. 4 is given. Then this in front of this decimal point, this figure gives what is the 10 to the power 3 power. This one is follows, this one is provided 10 to the power 3 or 10 to the power value. So 0 point. So you can consider this figure, this mantissa following or providing the like this one in the main, but that one provides the value in between 0 and 1. This is the one providing the value in between 0 and 1. You can find that one using a table, and then you can write y in 10 to the power 3. You can find the corresponding y value using the table 5346, and then you can multiply by 10 to the power 3. So it's another, it's opposite way now. It's other way around. So let's take this one. Antilog. Antilog means now we are calculating the other way around. So here antilog 0.0621. So what we can do, we need to find the 0621 inside this table. 0621. 06 No. 6021 is it? 6021. 6021. Oh, yeah, that one is there available. 6021 here. That one is directly available 6021. So 6021 you can see the corresponding value is 40. 40, yeah, 40. It's like 4.000. Huh? The corresponding value for this one is, you can refer the table inside and then identify 6021. Then the corresponding column and the row, you can read the value as 4.000. Then this is 10 to the power 0. You can see here this is 0. Next 10 to the power 0 means actual value is 4. So this is antilog of this value is 4. Antilog of this value is 4. So antilog of this value. So if you calculate this one, let's find out 0792 first. 0792. 0792. So now you need to refer this table 0792. 0792. That one also available. 079 directly available. 12, it's 1.20. 1.20. The corresponding column and the row is here 1.20. 0 actually 1.200 in 10 to the power 1. That means it's 12. This is 1, so 1 is 10 to the power 1 negative. So then it is 12. This one 2553. 2553. 2553. 2550. That one also directly available. So it is 1800. 1800. හරි මේක ඉන්නේ එතකොට 18 කියන්නේ 1.800 into 10 to the power 1. That means 18. That one is again 18. Antilog of this value is 18. This one 7553. Let's take 7553. 7553. 7553. 7553. 7553. You can see 7553 is not available directly. 7551 is there. We need 7553. 7551 is there. So then you can write 7553. How do we create that one? Here you can see if you add 2, then you can give 7553. So let's take this one. Make a tawulak, you can take either 2 or 3, doesn't matter. So I'm taking 7553. 7553. 7553, you can take 5692. That means 5.692. 5.692. 5.692. 7553 only. 7550, yes. It's 5692. 5692. 5692 in 10 to the power 2. Because this is 2 point something. 10 to the power 2. That means you can find right 569.2. 569.2. Okay. So that's the way to calculate the antilog values. Antilog values. Okay. Super easy. So let's calculate how to find this. I need to find this log 220. I need to find root 220. How do you find that? Take the log from the both sides. Log x equals log 220 half. Take the log. And then we know if you take a log, get a half log 220. So then take the log 220. You know, if there is a half power, you can take in front of the log. So now you can find the log, use the logbook and 220. It's in Sanskrit is 2.2 in 10 to the power 2. 2.2 in 10 to the power 2. Yes. So then we can write it's 2 point something. 2 point something. That's something you can refer, you can use the log value, okay? It's 22 balana dinna. You can refer this column and row 22, 34, 24. 3424. 3424 is 3424. 3424. So now you can see this is the log value of 220. And now it's divided by 2. You can divide by 2 now. So now divide this by this one by 2. So it's 1 point. You know how to divide this one? 1, 7, 1, 2. So this is the half value of that. So now this is the log x. But we don't need the log x, we need the x. So what we can do, we take the antilog of that. So then x equals antilog 1.1712. So now earlier we need x equals root 220. Sorry, we need x root 220. Then log x equals log 220 to the power half. I can take the power half. I mean, you can take the half out. Then log 220. Then I can take half into 2.3424. Then take the half value and finally 1.1712. Then antilog 1.1712. So we know this is 1712. So we need to get 1712 using antilog. 1712. 1712. 1703 is available. 1712. We need another 9. Right? I think. So you can take 14, 8, 3. 14, 8, 3. 14, 8, 3. 14, 8, 3. 14 in 1.4883. 1.4883 into 10 to the power 1. This is 1. So then you can finally write 14.83. That is the x. So earlier what we can do, put the log of, take the log of both sides, and then you can find the log x in this way, 1.1712, and take the antilog again to find the x. So then you can take this is the square root of 220. This is square root of 220. Okay. So that's the way to use the log to find the square root. So you need antilog, log. So then let's do another calculation. Okay, so x equals square root of 5.41 into 9.34 squared divided by 7.51. Let's take something like this, square root of 5.41. So now in this kind of calculation is there in your exam. You need to find the value. So what we can take the log of both sides. So log x. So you can take log. So direct write that. So this is half. So you can half log 5.41 plus. So this is a multiplication. We are taking the log. Something like this. So what we are going to do now, we are applying the log for the both sides. Square root of 5.51 into 9.34 squared divided by 7.51. So you know if there is a multiplication, you can write that one addition. If there is division, you can multiplication difference. So what we can put, you can write this one half log 5.51 plus 2 times log 9.34 minus this is log 7.51. Half log 5.41 plus 2 times log 9.34 minus log 7.51. So now you need to get these values. Half log 5.41. 5.41. Can 54.1? 54.1. 54 1 54 1 54 1 54 1 again mea 72 73 32 73 32 73 32 0.7332 plus 2 times this is actually this is 10 to the power 0, so I can put 0 point something. 5.41 is 0 point something, I mean 10 to the power 0. Again 5.41 is 10 to the power 0, it's 0 point something. Here also 0 point something. 9.35 10 to the power 0. So 0 point something. So 9.34 10 to the power 0 means 1, okay. 9.31 or 8 to the power 0, 0 means actually 1. That's why I'm taking that way. 9.35 10 to the power 0 is 1. Okay, so that is 9.34 again. So 10 to the power 0 is 0 point something in between 0 and 1. So 934, 934, 934, 93, 934, 93, 93, 934 क्या है मेरा 9704, 934 means 9704, 9704, 9704, 9704, 04 I think. 9703, sorry, 9703, 9703. DD. Okay, minus. Again, this one is 0 point something, 0 point 75 1. 75 1. ඔච්චරට යන්නේ නැහැ විභාගෙට මට මේ ස්ලයිඩ් එක ගන්න කරන්නේ 75 1. 75 1 means this one. 75 1. In the exam, you can directly write those things with the help of logbook. 8756. I know only 8756. 8756, yes. 8756. Now you need to solve this one. So you can take the half of this one. 0 point. Then 6. Then again 6. And again 6. Okay. So this is this value plus 2 times this one. 6, 0, 4, 9, 1. Just multiply this one by 2. 6, 0, 14 can, yeah, it's like 18, 14, 18, 18, yeah, 9, okay, 1.9406 minus 0.8756. You can take the answer, you can take now, 6, 6, 12 minus 6, 6, 6 minus 1, then 6, 4, 10, 10 minus 7, 3, 3, 9, 12, 12 minus 8, 4. Then it's 1. I think it's correct. But හරියට නේද? සුළු කීමක් බෑ වගේ නැත්තම්. එහෙම වැඩි දෙන්න පුළුවන් හරි the exam, so double check in the exam. Okay. So in the exam you can double check if you want when you calculate this stuff. You need this one for what we call the chemistry, not for the combined math. Biology I'm not sure, but physics and chemistry, yes, you need. So this is the log x. Okay, now I need the x. Now I need the x. Now I need the x. So how do you find the x now? Antilog of this one. Because my goal is to find the x. So then 1 6 43 43 16 43 16 43 16 43 16 43 43 43 43 43 16 43 14. Then yes, there is 2 here. So then 27 27 0 27 0 1 27 0 1 27 0 1 27 0 1 27 0 1 into 10 to the power 1. 2.701 10 to the power 1 means 27.01 actually. This is the answer. This is the answer. 27.0. This is the answer. Okay. 27.01. හරි නේද එතකොට? ඕන කැලේ ගහලා බලමු ෂුවර් නැත්තම්. Let's see whether this thing is correct. Square root of 5.41. බලමු අපි හරි මම වැරද්දක් කරලා දන්නේ නැහැ කොහෙද? 9.34 squared. Divided by 7.51. 27 something that. 27.0 is 100% correct. 27.0. Hurry. I use the calculator and check that. Yes, correct. So likewise, you can do the calculation. Simply, you can use whatever unknown calculation as x and then put the log to the both side, and then you can see finally this multiplication and division convert to some addition and subtractions. So you can simply do the addition and subtraction and just small multiplication, and then finally you can convert again the log value to the anti-log, and then you can find the x. That's the way that you are using the log. That's the way that we are using log to find for the calculation, to find the final answer. Okay. So that is another one, but it's pretty easy. I think this one is the more complex one on this example. So likewise, you can do whatever calculation using log. If there is a bar, no need to worry. So bar is just think this one as minus. So not the whole expression minus, the values in front of this dot is minus. So when you take later then make arangyathi one ekak, so you can see here when you take when you add, let's take this is as example, let's take this is minus, so bar 1, and let's take this is 1. No, 1 again. Let's take this one is 2. Okay. So this is minus 1 plus 1 minus 2. Something you need to think this one as plus 1 plus 1. Again, this is minus 2. So this is whole expression minus. Okay. So then plus 1 plus minus 1 plus 1 minus 2. Then it is again plus 1. It's minus 2 again. Then I'm kidding. So this is minus 2. This is plus 1. This is minus 1. Plus 1 minus 1. 0 again minus 2 is remaining. So it's minus 2. Then this one becomes 10 to the minus 2. I'm just giving you an example, not this one. Now making it, you need to think this one as minus 1. Within our whole expression is a minus value because of this division. But this is only the bar values. Bar means in front of that dot, I mean next to the dot, this one is only the minus, this part is still positive. You can try, you can Google search. If you have any doubt, you can Google and you can self-study. I'm just guiding you. These things are basic stuff, but you need always log in your A-level journey. So refer the log calculation. Okay, so we can move to the graph and other quadratic equation and the simultaneous equation. I will do that one next week. Okay. So we have another supportive session. So in that supportive session, I need to discuss about the graph, gradient, intercept, and different shapes of graph. What is the y equals mx squared shape? What is the linear one? Likewise. So next day I'll do the simultaneous equation, quadratic equation, and then finally let's do the graph because we have enough time. Harida. Okay. So today we discuss, and you know Pythagoras theorem. Pythagoras theorem. When there is a rectangular triangle, you know the addition of two sides equal that not addition is of addition of the two sides equal to the square root of the hypotenuse. You know that, we can put that name. Okay. So yeah, so that is the Pythagoras theorem, and you need that one also. So here this one includes, so today we discuss indices, and then we discuss some important functions like binomial expansion. Then we discuss then we discuss degree proportion, what is proportionality, and then we before that I think we discuss scientific notation. Yes, scientific notation. And now, including all these cases, we learn about the logarithms, log functions, and how do we use this log to calculate some how do we get the log, and how do we take antilog, and how do we do that kind of calculations, how do we find the square root of whatever numerical value. So now that's the way to use those simple mathematical concepts. You need this one definitely. Chemistry, physics, you need log. Without log, you can't calculate. Okay, I'll share this PDF to the group, and you can refer that one. And thank you for the participation. This one is there in the YouTube. If you want to clarify, if you need any more clarification, you can rewatch. And that's the end of the today's session. Okay, this is the end of this today session. So see you on the next day. And this Friday we are going to discuss vertical motion under gravity. We can finish. So this entire day we are going to discuss vertical motion under gravity. Second week of August, we are going to the inclined motion under gravity. Incline. Okay. Yeah. So join for the paper class, join for the theory, English medium 2020. We have a separate English medium now. You can join with that one. So this is the second day of supportive mathematics. So we have another 1 day for the supportive mathematics, and then we can conclude the supportive mathematics. But I'm taking the Tuesdays for additional extra class for the August related to the forces. Right? So that one is scheduled for week 3 and week 4. Forces, characteristic of forces. Okay. So I'm using the same day, Tuesday at 8 p.m. for characteristic of forces. Okay. Good. So I think you learned something from this one. I'll share this PDF. You can try the questions there. And if you have any doubt, you can refer the video again and clarify and get the help. And you can use the AI also, you know that. Yeah. Okay, so I'll stop at this point. Thank you for the participation. See you on the next day. Okay then, bye.